Hello students, and welcome to the CompTIA Data+002 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 1 in the exam objectives by concluding Section 1.1. Our topic is data types. Let's begin. Our first data type is a string. A string is a data type that stores a sequence of characters. Characters can include letters, upper and lower case, numbers, and symbols, sometimes also called special characters, things like exclamation points, question marks, ampersands, and others. We use strings to represent names, addresses, and textual descriptions. When we create strings in our database, we can create limits on its length. We want to limit the amount of individual characters that can appear in a string to save storage within our database. To identify certain strings in a database, we can use pattern matching. This is a search query where we try to identify specific sequences of characters within a string. We also can search strings using concatenation. Concatenation is taking two different strings and combining them together. An example would be the words United and States. We can combine them through concatenation to find a string that says United States. We use strings in all of our standard relational databases, and we can configure the length when we create our schema. Another data type is a character, also abbreviated as char, C-H-A-R. A character is a fixed length string that we store in our database, or a data type we commonly use for fixed length values. Two common implementations are area codes and zip codes. Your area code is a 3-digit numerical identifier that identifies where in the country you are calling from. Your zip code is a 5-digit numerical value that identifies your physical address. This is an example of using a character where we can establish a 3-length string or a character for our area code and a 5-character length string for our zip codes. Related is varchar. Varchar stands for variable character, is one where we have a string that can have its length modified within the database. This allows for storage of different data points that will have various text lengths. Related is nvarchar. Nvarchar has the same functionality of variable length strings, but allows us to do so using multilingual. We use nvarchar for translation services. Our next data type is a null value. Null value occurs when we have a data value that is unknown within the database. A null value does not mean 0 or an empty string. It means that the value that is inputted within the database is unknown or undefined. For example, if we are trying to enter our zip code within an user input form, we want the user to only enter numerical numbers. If they try to enter letters, the database will return a null value because it is a value that is unknown for that specific field within the database. Another data type is spatial. Spatial data types are used for geometric and geographic data. It allows us to create points, lines, and polygons within our database to create shapes and find distances at specific points. Boolean is a data type that we use for binary decisions. A Boolean data type will return one of two values, either true or false, and if we are using binary notation, 1 and 0. 1 corresponds to true, 0 to false. We use Boolean data types for binary decisions, condition checks, status indicators, or flags that can occur within our queries to the database. We can use our Boolean data types for queries that will return either a yes or no or true or false value. Integer is a data type that stores whole numbers without decimal points. We use the integer data type for counting and identifiers, commonly used for IDs that we create primary keys within our database tables. Integers can be used in mathematical calculations with other integer values. We also can identify different types of integers based on their size and range within an array. Another numerical data type is decimal. A decimal data type will store numeric values with a decimal point or fractional value. We can identify how many value places we want our data type to go both from the left and the right of the decimal point. Values to the left of the decimal point, those are your whole numbers. Values to the right, those are your fractional values, tenths, hundredths, thousands, etc. And within our data type, we can identify how many places we want our decimal point value to go before we begin rounding. The third numerical data type is a float. We use floating point representation. This allows us to identify either very large or very small values by identifying how far we want to go in our calculations. We use floats for measurements and calculations that allow us to have a slight rounding error. The trade-off with floats is that we do lose a little bit of that precision. Our next data type is date and time. We use date and time for stamping, also called time stamping. This is where we can take all of the records within our database and format them based on year, month, day, hour, minute, second, whatever type of time fractional value we want to identify. We also can create stored records using a consistent time record source. Our next data type is a blob, a binary large object. Blobs are data types we use to store binary data, such as images, audio, and video files. Blobs are not human readable. It requires a specialized application to not only interpret but to translate the file. File sizes can be very large. We typically store them outside of the main database in either an externally connected or a nearby offline storage. A CLOB, C-L-O-B, is a character large object. A CLOB will store large volumes of character and text data. We use them for documents and log files. CLOBs allow us to exceed the length limit of your standard string types. Unlike blobs, CLOBs are readable text, and we can search and query them based on user input. CLOBs are commonly used with extensible markup language XML and web content such as HTML. A GUID, G-U-I-D, stands for Globally Unique Identifier. A GUID is a 128-bit unique identifier that we use to identify records across systems and databases. A GUID is formatted as a 36-character string and will be globally unique. We use GUIDs in distributed systems where we have no central authority that can assign IDs. And lastly, we have a UID, UUID. UIDs stand for Universally Unique Identifiers. UIDs are used to identify data within a distributed system. UIDs follow a standardized format that is defined by the IETF and will include different versions depending on your use case, such as database, cloud, or API systems. That will conclude our discussion of Section 1.1 and data types. In our next episode, we will move on to Section 1.2 in the objectives and discuss data sources. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your night.